Hi, this is Stephen Brower from Irvine Valley Community College. This is for CSIT 256, Computer Architecture and Assembly Language. And logic tables are something that you should have seen in a class prior to this. When working with Java, there were the and the or Boolean operators that you worked with, and you would have seen tables like these, the truth tables for the and the or and the not. And so just as a reminder is that in terms of what a logic table has, there's a Boolean expression that is represented in the table, and then there are the inputs. So in this case, x and y are the inputs to this Boolean expression, which is x and y. And then these are the possible inputs that there can be. X can be false, y can be false, x can be false, y can be true, x can be true, y can be false, x can be true, y can be true. And in the case of the and, it's only when both conditions are true does the expression as a whole evaluate true. The notation used for and is different between the Irvine book than the Stallings book. So the Irvine book has this caret, and which, by the way, on the keyboard, it's over the number 6. So Shift 6 will give you that. The Stallings book uses a period. And actually, sometimes what the Stallings author will do is he actually will just sometimes write AB. And we're supposed to know that AB is not a single variable with 2 letters. It's A and B. So the Stallings book has the and that either is the dot or the implied dot. He's not consistent, by the way, so it could lead to a little confusion. So be careful on the homework. If on the homework you see something like ABC, ABC is not one variable. It's A and B and C. Now, the other thing, the difference between the Irvine book and the Stallings book is the Irvine book use F's and T's. The Stallings books use zeros and ones. So 0 for false and 1 for true. So the truth table in the Stallings book, so 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, 1 and 1 is 1. And by the way, later when it gets to something like an exam, if I were to give you a Boolean expression that I want you to fill in, one, I'll give you both formats of the Boolean expression, the Irvine format and the Stallings format. You pick whichever one you want. And for filling in the logic table, you either can use F and T's, that's F and T, not F and T. You can use F and T's or zeros and ones. I will plead my case in a couple slides why I think you should use the zeros and ones, but we'll get there. Okay, so the or. So you did or in Java previously. It's where either of them, if either of the inputs is true, the expression evaluates to true, or even if they're both. So, okay, false or false is false. False or true is true. True or false is true. True or true is true. Now, the or in the Irvine book is this V, which is on the keyboard. Okay, keyboard, keyboard, not keyboard. Well, this one's on the keyboard. The Stallings book uses the plus for the or. Again, when you're going back and forth between the two, it is a little bit confusing. Again, on an exam, I would give you both notations, and then you would use whichever one you're more familiar or more comfortable with. So 0 or 0 is 0, 0 or 1 is 1, 1 or 0 is 1, 1 or 1 is 1. Now the nots, this right here is not on the keyboard, but it is represented in ASCII. And so one of the things that the Irvine author does is by having this as an ASCII symbol, it's one that actually can be printed on the screen very simply. We'll see later that if we load EAX with a number and then we call write car, it'll display the character whose ASCII value we loaded. Well, there is an ASCII value for that, And so it's just a matter of loading that and then getting that out. Well, this is the not. So not false is true, not true is false. What the Stallings author does is he actually has the underscore over the variable that's being negated. So not A is how that would be. The little bit of a gap here is only because I wasn't drawing it by hand, but not 0 is 1, not 1 is 0. And so again, this is something you should have seen from a prior course. In terms of filling in a logic table, we would have our inputs, and then we would need to go and then figure out for whatever the expression is, and these are just simple expressions that are here. And what I wanted, the reason why I didn't fill these in yet, I want to talk about the idea of short circuiting. So if we look at this expression and we see or y, well, anywhere y is true, the expression as a whole evaluates true. Well, y is true here, so this is true. Probably should be a little more obvious that this is a true. And y is true here, so this is true. And that's actually, in a sense, what Java does in terms of short circuiting, is that if it evaluates part of the expression, and in this case using an or, if part of it is true, it doesn't need to evaluate the other. Later when we get to chapter 6 in Irvine and we're coding, we actually will code where we have to do one evaluation first, and then if that evaluates, in this case if it evaluates true, we can move on. So now in the case where y is false, then we can go and look at what not x is to figure out the result of the final. So not false is true, and not true is false. So what I'm getting at, if we're trying to fill in an expression, that we can do our own version of short circuiting. And by the way, this down here is showing the Stallings equivalent of that not x or y. So x with the line over it, or y. This one over here, x or not y. And again, if I do some short circuiting, anywhere x is true, the expression as a whole evaluates true. So these last two lines here are the expression evaluates true because x is true. So then we only have to evaluate the not y with these two that are left. So not false is true, and not true is false. Okay. Now, when we have three inputs, now if you notice this is just Irvine, Stallings is going to be the next slide. When we have just three inputs, we have to be very careful that we get all of the possibility of these inputs. So if x, y, and s are going to be our inputs, if we have three inputs, we need 2 to the 3 in terms of rows. So we need 8 rows where they're different. False, 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 true, false, true, false, false, true, 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 false, false, true, false, true, 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 false, true, true, true. That each of these is unique in terms of the rows. The most common mistake that is made by students is that when they're building the truth table using the T's and the F's, they duplicate one or they miss a row. On the Stallings, and I'll jump ahead, what he uses would be zeros and ones. Well, if you use zeros and ones, and let's, I'm going to go into edit mode here. If we treat it like a binary number, in other words, 0, 0, 0, then if we keep adding 1, we can get to the next row. 0, 0, 1. Now if we add 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. We add 1, 1, 0, 1. We add 1, 1, 1, 0. We add 1, 1, 1, 1. So the advantage of using the ones and zeros the way that Stallings does is that by doing this, so when we have our inputs, if we start at 0, 0, 0, and we keep adding 1 until we get to 1, 1, 1, we have all of our inputs taken care of. And when we later get to one that is going to have 4 inputs, well, later when we get to 4 inputs, 2 to the 4 is 16. And guess what? It's going to look like the 4-bit binary for the hex. Okay. Now, in terms of the filling out this expression, since this is an OR, you can see my mouse, I can't see it. Oh, there it is. Since this is an OR, one thing we can do if we're filling in this table is we can just look at one side first. This might be easier to do the y and s, especially because they're next to each other. Because if y and s is true, the expression as a whole is true. Well, y and s is true here. Y and s is true here. So it doesn't matter what the right-hand side is, that because these lines here, y and s, since y and s is true, doesn't matter what the right-hand side is, so I just filled those in pretty quickly. So now that would mean that the empty rows that I have is based on the right-hand side. Well, when I look at the right-hand side and I see x and, well, anywhere x is false, then this expression will evaluate false. So anywhere that x is false, this expression would evaluate false. So we don't actually have to look at the other part because that's an F. Because, and so now here, these the x is true. And so that means the only thing we're now looking at for these 3 remaining rows is not S. So not false is true. Whoops, sorry. Not true is false. Not false is true. So in terms of building a logic table, is that we can build it in stages by looking at part of the expression. And remember, so what I did first is I looked at the left-hand side, the y and s, and I did those two first. Then when I looked on the right-hand side, I saw where x was false, false in anything is false, and I filled those in. And so this way I only had to look at not s for a handful of rows. What both books will show is that sometimes they'll have intermediary columns. And what I mean is that they actually might put an additional column here, y and s. Then they might do an additional column, x and not s. And then the final result is sort of ORing those two columns together. It's personal preference whether you want to use the intermediary columns or not. I didn't use it on this slide here. And this is here showing now intermediary columns. And so if we do have intermediary columns, so this would be like the y and the s, we would be evaluating, which unfortunately the downside of using intermediary column is you actually would have to fill in all of the rows for the intermediary column. It can just help when it comes to sort of like maybe checking your work to see that how you got to the punchline, not the punchline, but the final result. And x false. Maybe I should hit pause. And so now that I filled in this intermediary column, with part of the expression, now in terms of this final expression, I'm just ORing these together. And hopefully, and I actually didn't go back and check, I should really double check that I'm actually ending up with the same result for both of these. Otherwise, I will cry and cry and cry. Okay, and so then if I look back, so false, 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 true, true, false, true, true, false, 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 true, true, false, true, true. Woohoo! Okay. So that's, well, there's going to be a later video that will look at Carnot maps, but this is kind of what's covered in Irvine chapter 1 and the first part of Stallings chapter 11. I lost my mouse. Here's